Okay, here we're going to look at solving nonlinear systems. Nonlinear means they aren't just lines, okay? Like this one's not a line, right? So we have three ways. We do it graphically, sometimes by substitution, and elimination. It's nice if you try to visualize what's going on here first to give you like an aid in your head to see, hey, how many solutions might there be to this, right? Let's see what types of graphs we actually have. If you solve these both for y, right? The first one, I add a x squared to both sides. And then the second one, I subtract an x on both sides. You should be able to identify both of those, right? This one here, parabola. This one here, line, right? So they should create. You could graph them and find out where they intersect, and that's one way to find the solution. So let's look at that. Notice there's my parabola. That's this guy. There's my line, negative slope, going through positive 2, right? And look where they intersect. Negative 3, 5, and 2, 0. So here we have actually two answers to the system, right? Could be these two because they intersect twice, or ones if the line looked like this. No answer, right? So it could not even hit that parabola, so it could actually be no answer. Or it could actually intersect in a way that there might be just one answer, right? If the line was vertical, it could be one answer in this case. There's other ways, maybe it was like this, going on slightly vertical, maybe more just like that. That's still a slant. Could then just be one answer. This one would never intersect with that one, right? So there are some options of having no answers, one answers, or even two answers when you have parabolas and lines. So let's solve it by substitution now. We got to be careful, because if I solve for the x squared, I could get a plus or minus, right? So when you're doing substitution, solve for one of the variables that doesn't have the square in it. So for example, I will maybe solve for y. If I solve for x, then I'm putting things into there. That'd be fine, but just don't solve for the x squared. Let's solve the bottom one for y. So I subtract x on both sides, so y equals minus x plus 2. That's this one. Now I'm going to take this minus x plus 2 and put it in for the y there. Okay, so right there. So I have negative x squared plus negative x plus 2. I always put my things in parentheses when I put there, because that's y, equals negative 4. Okay, then I can drop the parentheses, negative x squared minus x plus 2 equals negative 4. Let's move everything over that way so that we have positive x squared, right? So add an x squared, okay, add an x, and subtract 2 from both sides. Okay, now I can factor that, right? Let's see here. What two numbers multiply to negative 6 but add up to 1? That would be plus 3 and minus 2. So my answers are negative 3 and positive 2. So that's just the x value though, remember? Negative 3, positive 2. Those are two values for x. Now what are their y counterparts? Well, go right back here. The first one, if x is negative 3, the opposite of negative 3 plus 2, right? That would be 5. The other one, negative 2, right? Opposite of 2 plus 2 is 0. So the points 2, 0, and negative 3, 5 is where they intersect. Is that where it was? Negative 3, 5. Yep, and 2, 0. So that's solved through elimination. Now I have one for you to try. The same one, but I'd like you to try it with elimination. Well, that was substitutions before, this is elimination. So now I'd like you to solve it. And a hint, though, you can't eliminate the x squared with an x, right? So you can only eliminate y's. So try that and see if you get the same answers as I did before. Okay, here we are. I'm going to eliminate the y's because I can't do the x's. So I'm going to multiply by negative 1 on top. This whole equation. I'm going to get x squared minus y equals positive 4, right? So that's this one. So now I can add these two together. So remember, these don't add together, so it's x squared plus x, right? These cancel, equals 6. Subtract a 6 on both sides. Here we are, back to our friendly factoring technique. The plus 3 and the minus 2. Here I have my negative 3 again and my positive 2. Again, kind of set them up here. And then go and get the other values. Where do you get them? Well, choose this one, or this one. It doesn't matter, right? Or this one here. Let's choose the x plus y equals 2, since that's the easiest, right? Okay. X is negative 3, so negative 3 plus y is equal to 2. Add a 3 to both sides, 5. Okay, there's that one again. 2, again, make x equals 2, so I'll take 2 plus y equals 2. Subtract a 2 on both sides, y is 0. Alright, there are both of the answers again. These two lines intersect at those 2 points.